In the vast, unending canvas of space, where silence reigns and stars are born and die across billions of years, something flickered. Something small, something persistent, something undeniably strange. It wasn't a star. It wasn't a galaxy. It wasn't supposed to be there. The James Webb Space Telescope, humanity's most powerful eye in the cosmos, had been scanning a remote patch of sky, a region thought to be largely empty. Designed to peer into the very birth of the universe, it instead saw something else. A single, consistent source of light in the darkness. One that blinked and pulsed in a pattern that wasn't random. The pulse repeated itself with haunting regularity. It wasn't a cosmic accident or a lens flare. It wasn't a known type of celestial object. Natural bodies, even neutron stars or quasars, don't exhibit this kind of behavior, not with such precision and rhythm. This wasn't interference. This wasn't an equipment failure. This wasn't noise. This was light behaving with intent. And the implications, quietly whispered in scientific halls, were staggering. Could this be artificial? Was it created? And if so, by whom? James Webb's mission was never small. It was launched to witness the birth of stars, to observe galaxies as they first ignited, and to explore the very structure of the universe. But embedded in its programming, though rarely talked about, was another goal: the search for anomalies, the unexplainable, the impossible, technosignatures. Unlike biosignatures, which look for chemical traces of life, technosignatures are signs of technology, of civilization. These might be structured light patterns, symmetrical emissions, or signals with mathematical regularity, things nature doesn't usually do. This new flickering light came from a sector of sky long considered a cosmic desert. Astronomers had charted it, cataloged it, left it alone. But now that desert flickered. The light wasn't bright, but it was intentional. It blinked every 17.6 hours, perfectly, predictably, without deviation. Astronomers ran the data through every known filter: gravitational lensing, number microlensing by a rogue planet. Not likely. A variable star. Didn't match. Again and again, the pattern repeated, like a heartbeat, like a beacon. James Webb doesn't just detect light, it deciphers it. Every photon Webb catches gets broken down into its component wavelengths, allowing scientists to determine the chemical composition, temperature, motion, and structure of its source. But this light wasn't normal. It didn't produce a wide, natural spectrum. It didn't look like the radiation from a star or a galaxy. Instead, it was narrowband, confined to an incredibly tight range of frequencies. That's rare in nature, but it's common in human technology. Narrowband signals are the backbone of artificial communication. From Earth's satellites to military radar, this kind of emission is used for focus, clarity, and long-distance data transmission. The signal's bandwidth, its periodicity, even the subtle shifts in frequency, it all resembled something crafted, not born. Could it be a lidar beam from an alien ship? Could it be a laser transmission across interstellar space? Some physicists began analyzing the light's waveform. It showed signs of modulation, like data might be embedded in it. Others speculated it might be the waste heat from a colossal structure, perhaps even a Dyson sphere, partially cloaked from view but leaking trace energy. Each possibility was more unsettling than the last. As word of the anomaly spread through the scientific community, debates ignited like wildfire. Prestigious journals scrambled for preprints. Online forums exploded with speculation. Was this the discovery of the millennium or a cosmic red herring? Skeptics stepped in quickly. Some suggested a never-before-seen type of pulsar, a neutron star spinning with extreme regularity and beaming light toward Earth. Others posited that perhaps a black hole, in conjunction with gravitational lensing, had created a temporary illusion of patterned light. But none of the models fit perfectly. And that's the problem. The pulses were too precise. The spectral lines were too clean. The consistency? Unnatural. Webb has recorded hundreds of exotic cosmic events since launch: colliding galaxies, supernovae, black hole mergers. But this signal refused to obey the rules. It wasn't violent, it wasn't decaying. It was calm, stable, as if it were engineered. And scientists knew one terrifying truth. Nature rarely builds with symmetry, but intelligence does. When the SETI Institute received the Webb data, alarms went off. This wasn't the usual static-filled maybe signal that faded after a few hours. This was persistent, repeatable, predictable. Everything SETI dreams of. The Allen telescope array immediately pivoted to the coordinates. So did China's FAST radio dish and the Green Bank Observatory. No radio signals yet, no microwaves, no digital transmission, but the light remained, and it kept pulsing. Some researchers theorized that we might be observing a quantum-entangled communication system, something so advanced that our current technology can't even detect it properly. Others ran computer simulations of encoded optical signals. Could the flickers be binary? A message? A map? SETI scientists, once dismissed as fringe, were now center stage. Funding offers poured in. Government agencies made quiet inquiries. Because if Webb truly detected artificial light, if it caught a message from a distant civilization, then we are on the brink of answering humanity's oldest question. Are we alone? And if not, who is out there? Science can measure the signal, but philosophy must interpret it. If this light is artificial, it means someone else exists. Someone who understands energy. Someone who can harness and focus it with unimaginable precision. Someone broadcasting across the dark not because they want to be found, but because they can. Thinkers from every discipline weighed in. Some saw hope, a sign that intelligence survives. Others saw danger. If we can see them, they might already see us. Debates over the Fermi paradox reignited. Maybe the reason we haven't heard from anyone is because civilizations either self-destruct or choose to remain silent. But what if this one didn't? What if they're reaching out? Should we respond? Can we respond? Because light travels both ways, and we've just become visible. The cosmos feels different now, heavier, more alive. James Webb wasn't designed to find aliens. It was built to uncover our beginnings. But maybe, just maybe, in reaching for the past, it touched something waiting in the present. Maybe the light isn't a warning. Maybe it's a question written in photons, pulsing across the dark. Are you out there? And for the first time in history, we're on the verge of answering. Not with words, not with math, but with wonder. Because that flicker in the void wasn't just data. It was a knock at the cosmic door. And now the universe is waiting to see if we're ready to answer, or if we're still too afraid to listen.